consider the feedback of hydrology of climate change, we know, or at least you said now, that the uncertainties are very low. But is it not simpler to take into account only a model which is simpler and so more robust without taking into account the...
Yeah, the problem, you know, everything is related. We are trying to make a general discussion, but everything is related, and the answer is related to the kind of project that you have to deal with and your audience. So, you know, if the project is very important, like think about, the Millennium Dam on the Blue Nile, which is one of the very huge dams that have been recently built. There are, in damming, we slow it down, but there are still some countries that are building huge dams in China and in the East in general, because they are building some, in Vietnam they are building some project, and also the Millennium Dam is in Ethiopia, is on the Blue Nile. It's huge. I mean, it's something that is really, and okay, this is a human intervention that has an impact downstream, and because it reduces the flow in several countries, and this is quite easy to understand. The political consequences are not easy to understand, and the political consequences may be a war of Egypt against Ethiopia, and this affects indeed the operation of the dam. So in this case, I would say they created an international committee of experts that is still trying to reach a compromise for the management of the dam. Because if Egypt is asking for a minimum release, Ethiopia doesn't want, of course. And so this is an example where the feedback between society and hydrology intended as operation of the dam, it's extremely important to consider. There are other cases in which you may deal with an audience that is convinced that the feedback is important and you are not. And in this case, you have to find the right way to convince them that either the driver is not important, like climate change is not important for designing the water supply system of Bologna, or what a debate in which I was involved in a design project of an irrigation system for a small agricultural area here in Emilia-Romagna. And they were really convinced that climate change was important, and you know, it was. I'm not sure I succeeded in convincing that other factors, other drivers were more important than climate change. In some cases, it may be clear that the feedback is not important. So, the reply to your question, as an engineer, I would say, look, you have to look at your project, at your audience, at the political context, and understand what's important and what's not. There are things that may be technically not important, but societally important, and require a different approach. Yeah?
If you choose for the first approach with the feedbacks,
yeah.
How you decide when to stop?
This is another good question, and let me say, I would reformulate it in this way. How do you decide the level of detail? Because in this case, this is not circular. Once that you estimated a model that is describing both of them, both climate and hydrology, then the solution is just one, which takes into account all the possible feedbacks. And it's not an iterative process. It may be iterative if you keep the two models separated. And therefore, you have a model for climate, a model for hydrology, where hydrology is an external forcing of climate, and climate is an external forcing of hydrology. Then you need iteration to converge. But at the end of the story, you converge to a solution where they are in equilibrium according to the feedback that you considered. And if you build a unique model, then you have a unique solution, which is equilibrium. So every time that you study equilibrium, basically, in any process, and you identified all the drivers and feedbacks, then if a solution exists, it's unique. It's not something that is circular. It's not like an Excel sheet with formulas referring to each other. And in this case, the question is how to build this model and what is the level of detail, because there are feedbacks that are important, others that are less important. Okay, let me move forward with the last slide, and then we open up discussion, a longer discussion. Okay, this is the last one. I'm sorry, it's still, let me see. I make an effort to split the slide in two, because I don't feel comfortable in this way. So let me see. I'm sorry, I didn't realize it on the PC that the font was changed. So let me see if I can. Okay. Still. Okay, now it should work. Okay, this one works, just 1 second. Okay, good. Future scenarios, okay. So, what are future scenarios? They are projections that are derived by using our models of what will happen into the future. And keep in mind that one thing that I wanted to notice here, which I emphasized, that scenarios are not predictions, they are called projections. Again, this is something that is debated among researchers because it's not clear the difference between projection and prediction. Basically, some scientists had the idea of calling them projections because it doesn't give the feeling that they are granted for sure. If you call something a prediction, people, your stakeholders tend to assume that what is predicted will happen, which is not correct. We should make clear that there is uncertainty, and therefore there is the tendency now to call them projections, and the scenarios are projections, so they are not trying to predict what will happen. They are just meant to reproduce possible future conditions. And basically, what is the way of getting the future scenario? Typically, you use the model that you previously identified, the previous step, to extrapolate into the future. And if it is linear regression, it's very trivial, but even if it's a more complicated model, what you do is just to update your inputs, and so if it is a rainfall runoff model, you don't use historical rainfall to run it, you use a new rainfall, which is predicted after climate change, and then through this new rainfall you estimate through the model your future conditions, and that's perfect. Scenarios are then uncertain, and then we come and we need to discuss a bit more about uncertainty assessment, and it is a challenging task. When you talk about uncertainty assessment of human impact, this is very challenging. It's challenging because it's difficult to communicate it, so there is a rich literature on communication of uncertainty as well. And it's challenging because for many reasons that I already mentioned. We don't know the process in detail. There are several things that are affecting our capability of predicting. And what is the product of uncertainty assessment? The product is the confidence bands. And this is extremely important. There is today an increasing awareness that decision makers don't need just a prediction. When the prediction is uncertain, they need to estimate this uncertainty. And one thing that I noticed, for instance, I like to go in the mountains in the Alps, and especially in the Trentino region, and they have a very efficient, in the Veneto region, they have a very efficient regional meteorological service for the mountain areas. It's very, very good. And recently they started to, after the prediction, to mention, to classify the reliability, like good reliability, optimal reliability, reduced reliability. And this is a way to provide confidence bands. And in this case, they are not providing a quantitative estimation. Confidence bands are quantitative. They are providing estimation based on categories. But because they understood that besides giving the prediction, given that their predictions are usually very good, people used to take the predictions for sure. Like this will for sure happen, and then they had legal consequences, like people that was suing them because the prediction was wrong. And therefore, this is a clear indication of what is the meaning of providing uncertainty. And of course, a very expert user knows that a prediction is uncertain, and an expert user also is able to integrate, to understand whether a prediction is uncertain or not. In the past, I used to see if they changed the prediction from one day to the subsequent day. They make prediction for 3 days, and if I saw that for Saturday, the prediction was always the same. 3 days in advance, 2 days in advance, and the day before, this was for me a sign of reliability. If I saw that they changed the prediction every day, I assumed that they were not sure. But this was for an expert user, because I was trying to interpret what's going on. But then with the massive widespread use of meteorological prediction, people started to keep them for granted. You may have heard that some people filed, some hotel owners filed the National Meteorological Service because the prediction were wrong and they had a damage in terms of income. So you understand from these examples that providing an estimate of uncertainty is important. And also, I think these examples also clarify why it's important to tell people that a prediction is uncertain. Because if they take it for granted, there are risks. Okay, and this is our usual output, confidence bands. The key question is, how can I estimate uncertainty? In the case of linear regression, I told you, you have a theory, assumptions and a theory. For the case of linear regression, we are in a similar situation. For other cases, instead, we have no method, no suggested method. Hydrology uncertainty assessment in hydrology, for instance, it's a very active field of research. It started about 25 years ago, and still it's very active. And also for climate science, for climate science, it's a very active field of research. And what's important to learn for you is that when we talk about uncertainty assessment for environmental processes, whatever is the method that you use, we are still in the context of a research question. So every time that you see predictions without uncertainty assessment, you have to assume as an engineer that you are not happy with that and that you have to better understand what's going on. Any time that you see a prediction with uncertainty assessment, you have to wonder, to inquire what was the estimation method and make your own assessment on how much it is reliable, because uncertainty assessment is by definition uncertain. So be very careful to that. When using predictions, when communicating predictions, keep into account that as an engineer you should also deliver an estimate of uncertainty, but you should also be very clear in specifying what is the method that you used. We are not focusing on uncertainty assessment because it's something that is very extended. It's not our purpose to focus on it and to learn these methods. Some of them are very simple, some of them are complicated, and if you will need in the future to learn something, you will find a rich literature. Not easy to understand because it's not textbooks. There are some textbooks, but still not complete. But you will find information. For now, we stop here. And the main issue is the concepts that you have to have clear. Now, I would like to propose, so you are 4, 7, 9, and I make a proposal to you. Group in groups of 2. I give you 5 minutes while I take the camera off and everything. And you elaborate, one group is 3 persons, because, one group is 3 or one group is a single person, you decide. And you elaborate one question per each group, and I take 10 minutes to reply, and then we close at 10 to 2. Okay? So the lecture is finished, I take off the camera, and you have 5 minutes. And you have, I would prefer that you group. Okay, 2 persons, and this is a new experience for you, but I think it is very productive. You will see that you will find 4 interesting questions.